Hi, I'm Gary Leong, the Director of Industry 4.0 and Ecosystem Development. So here, we're going to share with you V1 in application. Here, we will do connect, visualize, and ProAct. But first and foremost, we have to do connect. So let's go to this room where our Senior Solutions Engineer will share more about the application. Come, let's go. Hi, Ryan.
Hi, Gary.
Ryan is our Senior Solutions Engineer. He will share with us more about Connect. Ryan, can you share with us more about Connect?
Yes.
Okay, thank you.
Let me show you.
So can you share with me how does this connect to the legacy machine over here?
Of course. So let me show you the first one. It's a vibration sensor. So first thing we need to do is we're going to get the wires to connect to the sensors. Okay, so first thing we need to going to connect from here. Okay, so second step, we need to going to connect to the IoT gateway box. So in order for the IoT gateway to get the data from a sensor itself. Okay, so now we are going to connect to the machine. Okay, so we need to going to understand the machine functionality. So which part you need to going to do the monitoring the vibration effect. So for the first thing, if I'm going to choose this guide rail, so what I'm going to do is I will going to put this sensor over here. Okay, so it's simple as that. Once you already been connected here, the V1 chart will going to show the trend of the vibration inside the time chart. So just as simple as that.
Thank you, Ryan. Yeah. What about this?
Okay. So this is the air compressor. Okay. Whereby that most of the industrial use case, it will going to be used a bigger size and a smaller size. Right now, we are going to use a demo kit. Okay. To showcase how we're going to collect the data from the air compressor. So I will going to use this air pressure sensor here. So what I'm going to do is, once I already been connected everything, I just simply plug over here. Okay, and then if I'm going to activate here, okay, all the data will going to be collect from this sensor, and then we'll pump it to the chart here. Okay, so just simple as that. Yeah.
Wow, that's impressive. Thank you, Ryan, for sharing. So that's how the connectivity to IoT sensors, to air pressure, and also vibration to a legacy machine. So in this part, you have just seen how we use different types of IoT sensors to connect to a legacy machine. So in this particular case, the legacy machine is around 15 years old, where digital connection is no longer available. So we have to use different IoT sensors to connect to this part. For example, this or this. And from there, we connect to collect the data, where Ryan has already collected the data and then visualize it in the V1 dashboard. So over here, let's go to the next part where we do visualization and analyze. Hi. Okay, I'm going to bring you to our CCC room where we're going to witness a discussion from manufacturing and planner and also business development. So they do live discussion in this room, and let's go and see what they're discussing about. Okay, let's go.
Hi, Gary.
Hey, hi, good afternoon.
Good afternoon.
Okay. All right, let me just introduce the team to you. This is Lai Ching from Planner, Wong from Manufacturing, and Jiaming from Business Development.
Okay, let me start our meeting.
Okay.
I still do a summary first. This one, our production is totally, we are building 15 machines in the pipeline. Then is 8 unit is the X2X and 7 unit is the XLT. Jiaming side or Gary side, any update or any orders coming?
Yes, this afternoon when I was walking to the office, I received a call from a loyal customer in China. So they told me that they want to increase one more machine. So the machine is S2EX, similar to the previous order. However, the problem is that they need the machine in 2 weeks' time.
Oh, very sure.
Quite challenge. Yes, I agree with you. It's quite a challenge. Of course, I didn't promise him whether he can deliver or not. And I asked him when is the PO. He says that if he get the answer for us, we can do ready the machine within the 2 weeks time. We will raise the PO within today. Tomorrow we get all the paperwork done. So we should get the PO by tomorrow.
Okay.
So that's why I call the urgency of this meeting, and then see if there's any slot or whether we can do this delivery for him. A miracle worker.
Okay, I think for production side, the base will be no big issue. But if let's say we want to build a new one to fulfill this order, like the lead time almost is a 23 day, so impossible to make it lah. So, Lai Cheng, do you have any suggestion here?
If look from here, the production part, like in queuing, I think maybe we can just suggest this machine is 3531, this machine, because the material, as I know, this material is almost full. Then the cabinet or server rack also will come in on this 2 day. Suppose can meet the delivery date. But not sure the production side any concern on this.
This one, 3531. This one machine just in integration stage. Then, like that's all I can say that material still got maybe will deliver on this few days. So including the alignment, testing, buy off everything, like it's need to more than 2 weeks. So it's quite high risk if they say we use this one. Yeah, not so suitable. Any other suggestion? Yeah. Or any other machine?
Look like this, we have to choose a material that almost complete. Just can meet the short lead time delivery. Or we choose this machine 3525 because this machine already on inside OQA already.
Yeah, if they say this one is better.
3525. Unfortunately, this is not a suitable machine to release because the customer already engaging with our logistic teams, and customer actually requests for on-time delivery. So I don't think this can be released. Any other options, Lai Cheng?
If look like this, I think we only have the last choice. This one 3526. This one is already done in system test. I think we left only weeks we can complete this machine. But this machine we still short on some material. That machine option will log in on this. I think within 3 days we'll log in. But not sure if production still able to meet the target shipment date or not.
Okay, for this machine, I think production we can do OT to perform it to expedite this one. Then for the option part, like as long as before buy off time, we receive the part to be no issue. So yeah, Jiamin side, you okay for this arrangement?
This customer requests the machines by next month, so should be no problem to support this urgent PO.
Okay.
But one question.
Yes.
What is the next available delivery date to replace back to this customer?
Yeah, I think this one, if they say we want to build a new one to replace it, since you say that the customer not so urgent, I think we can catch up the timeline for it. As long as we receive, production can receive the material on time. Yeah, like change side.
Yeah, I think from my side, I will do the expediting to buyer side and work with buyer, see any bottleneck or not. If any issue, I will feedback to you all again.
Okay, great. Then perhaps we can share the quotations to you first so that we can do the comparison on configurations. Then only we decide on the new delivery date.
Can.
Also, we update in the production schedule for all.
Make sure also that the quality, everything is checked in order and complete the quality and then check in so that we don't have any issues.
So this one we will ensure it.
Okay, so in this case, I will contact the customer shortly and then inform that we have good news for them.
Yes.
Then we can deliver within 2 weeks. Okay. Yes, I think that is a good news. Thank you guys. Thank you to the team. Any other updates for?
Yeah. For my side, I will update stakeholder regarding to machine shopping. Yeah.
Okay.
So should be no problem. Thank you.
Yeah, let we work together. We make it happen.
Okay.
Okay, thank you.
Thank you.
Thanks.
So just now you have seen a discussion where we are having it in CCC room. So among the production team and also a business development and planner, we discuss how we can swap areas, swap machines, and to fulfill certain customers' demand. Because customer demand and also material shortage and other areas can disrupt the production capability. So we have to do having these insights, having these visualization tools so that we can able to make a good decision and fulfill as much as possible for business. So with this,
This is one of the areas we use it in manufacturing here in VTROX. This is where we do visualization. So next, we will go to ProAct, which is proactive action. And we will use artificial intelligence like machine learning and deep learning. So let's go.
So today I'm going to show you what we have on this training platform. So I will be pausing around to explain. So first, what we have here is we do have a series of steps that you can make use of this AI platform. You can collecting your data and submitting to this platform. We have a data management modules that helps you to collect all the data and do the manage on the data. And then you may able to perform certain labeling on it. After that, you can train up a model, make use of the VTROX proprietary AI model. And lastly, of course, after you train the model, you want to know whether the model is good or bad. You can use a test module to test it out. And finally, we do have our inference service that deploy in each of the system, so that you can manage your deployment. What is the AI model that newly trained that you would like to deploy into each of the, we call it inferencer. So with the series of pipeline, it allows you to do any image analytics on whichever quality detections in your manufacturing field. So over here we do have certain details on it. I will explain through. With that, as a start, you can create a projects on it. So by all means, you may detect on electronic components, you may detect on different packages, or probably you have a final assembly that you would like to take snapshots on it, so that you want to replace your QA that looking around on that particular final package assembly. So over here, this is the component level example. We're starting to create projects on it. We call it Optimus 001. And then you create the data set. So the S type represent the so-called SOIC packages. And then you're starting to upload all your images and your metadata into this platform. So it allows you to either upload it from the platform itself, or you using certain API or services to streamline your data into this platform. All right, so there are different kind of data set that you can create it on it. So we make it fast. Fast forward, you can review some of the images that you uploaded in the platform. And then for this use case, we are trying to do we call it body detection. For example, we just want to do a simple case that we wanted to detect if the body is there on this particular component, where's the location. So you're starting to do a labeling on it. You provide the image, you draw a box on the body. You can do certain adjustment on it. So you at least need to submit 30 or 100 images into this platform, draw on the bodies. You can do certain filters on it, different type. All right, and then you can just do some review on the data, and then after that, let me fast forward a little bit. So after you label all your images, right, you could starting to create something we call it a virtual set. So a virtual set allows you to sometimes you may upload a set of data maybe every week or every month. So virtual sets allows you to combine different kind of data set into one in order for you to start the training of the model. Right. So this particular virtual set is very useful when you want to manage your data in the way that you might every certain quarter you have a new package kind of image that you want to upload into the servers in order for you to facilitate the new training. Okay. So afterward, let me fast forward a little bit. So after that, you can also create a test set. The step will be pretty much similar. So you can create your desired testing set. You may put all the difficult cases into this test set, so that you could verify the model that you created later on. Could it be satisfied your production cases? You may want to reserve certain kind of like new cases, abnormal cases into this test set so that you can test the model later on. Then we're starting to do a new training on it. So we call it like a body detection, object detection. Then we're starting to create a task. So this, it can go very simple, it can go very complicated. All right. So over here, it is a moderate cases that, all the parameter you do not really need to choose, it will suggest you by default. And then you start to train your model. So during the training of the model, right, we do have visualizations for you to take a look on something, we call it a training loss. You can see that, you can imagine that the lower the graph is, the better the model performance is. All right. So you will continue to train until it converges, or you may, stop whenever you're satisfied. Okay, I will fast forward a little bit. You can take a look. Each of the, we call it epoch, is each of the training cycle. You can take a look some result snapshot by this model, and then after that, we can test it out whether we can run the testing on using the model. When you're satisfied, we're starting to do a conversion. Make a pause here. So you can see for this step, it is basically after you're satisfied, this model is good, you could do a conversion and starting to move forward for the deployment. All right. So the conversion is just to convert all the satisfied model into a deployable model into the system. Okay. Right. So let me go through, fast forward a little bit. Okay. So over here, let me fast forward to the deployment. So the deployment, sometimes you may have multiple machines or multiple QA system in the field, in the production floor, that you could create multiple deployment models over here to deploy to different kind of issues or classification in the system. Okay, so the deployments and the inferencer. The inferencer basically allows you to connect to the service on the system itself, so that whenever you improve the model, you test it satisfied, you could send it in a real-time basis directly to the inferencer. It will take effects in the next snapshots. Okay, so with that, I think I will stop over here. So just to summarize the entire platform, we have a series of the ready-made flows for you to upload your images, to do all the deep learning analytics algorithms that you can train newer models in order to address the issues that happen in your manufacturing. So feel free to contact Vitrox if you would like to evaluate your issues. Is that solvable by using this AI training platform?
What you have just seen in this video is one of the examples of ProAct, where we utilize deep learning in imaging analytics as an artificial intelligence-based image processing after machine vision captures images for quality inspection. Most of the legacy vision inspection machines are image comparisons or rules-based processing. Therefore, with V1's AI deep learning, we can enhance the legacy vision inspection with additional AI post-processing to reduce false rejects and increase throughput. This is ProAct. In conclusion, we have shared with you V1 in 3 steps: connect, visualize, and ProAct. So what's next? Try it yourself. Assemble your small team to start a proof of concept, identify the need, and establish the impact that can bring value to your operations and company. If you need assistance, please feel free to contact us. Remember, with V1, it is just a click away.